Addition and subtraction formulas. This lesson will use the sum and difference identities. Your textbook calls them addition and subtraction identities, but they can also be called sum and difference identities. And one thing you might not have ever seen before with this notation, we have the plus minus that should be familiar to you. But in the cosine formula, there's an upside down minus plus. When you see that, it means do the opposite. So in the beginning, where it says cosine of alpha plus or minus beta, if there is a plus in that at the very beginning, then that means when you get to this part of the formula, you'll put a minus. Or if there's a minus at the beginning, then in the middle of the formula, you'll put a plus. You'll do the opposite. With the sine formula, since they're both plus minus, you keep it the same. So if there's a plus at the beginning, there will be a plus in the middle of the formula for sine. For tangent, it has both. On the top, it has plus minus, so you'll have the same as what you started. On the bottom, it has minus plus, so that sign will be the opposite. And you're also going to need the unit circle to work these problems, so it would be helpful if you have a unit circle in front of you, as well as these sum and difference formulas. There's a copy of both of those on Point Learning. It says find exact values. Whenever you see exact values, it means unit circle values, not your calculator, which is rounded. But 105 degrees is not listed on the unit circle. We're going to find two angles that are on the circle that we can either add or subtract to make 105. There's more than one correct answer to this, and you'll come out fine as long as your two angles either add or subtract to make 105. So if you look at the circle, just looking at the different angles, trying to end up with 105, you might see that 45 plus 60 makes 105. 45's on the circle, 60's on the circle, and when you add them, they make 105. So those are the two we're going to use. So what we're doing is the cosine of 45 plus 60. 45 would be the alpha in the formula, 60 would be the beta. Now look at the formula for cosine. When you're adding cosine, the formula says cosine of alpha, cosine of beta, and then there's that upside down minus plus. So since I started with a plus, I was adding, then I need to do the opposite and put a minus. Then it's sine alpha, sine beta. Now, it's okay if the 60 and 45 have been swapped. We could have used something else completely like 135 minus 30, but you'll come out the same in the end. Now, once you have the numbers into the formula, you're going to look those values up on the unit circle. So the cosine of 45 is square root of 2 over 2. The cosine of 60 is 1/2, and then there's a minus. The sine of 45 is square root of 2 over 2, and the sine of 60 is square root of 3 over 2. Now with the fractions, you multiply tops and multiply bottoms. That would be square root of 2 over 4 minus square root of 6 over 4, and then you can just put it all together in one big fraction, square root of 2 minus square root of 6 all over 4. The tangent of 15 degrees. So we want to find two angles that are on the circle that when we combine them we get 15. And there are lots of different correct answers to this, but I'm going to choose 45 minus 30 to get my 15. Now in the identities formulas, we picked the one for tangent, and it's going to be the tangent of 45 minus 30. 45 would be the alpha, 30 would be the beta. The formula for tangent says tangent alpha, and then it has the plus minus right side up. That means I use the same thing as what I started with, which is a minus. Then tangent beta over 1, and then it's the upside down minus plus, so I do the opposite of what I started with. Tangent alpha, tangent beta. Now look up those values on the unit circle. The tangent of 45 is 1, minus the tangent of 30 is square root of 3 over 3, over 1 plus, And then again, the tangent of 45 is 1 times tangent of 30, square root of 3 over 3. So 1 minus square root of 3 over 3 over 1 plus square root of 3 over 3. That could simplify down farther. It's fine with me if you want to leave it there. Just be aware the back of the book is going to go farther with that if you're checking answers. If you chose something other than 45 and 30, your answer might look different than this one, but that doesn't mean it's wrong. It just means we haven't simplified it as far as it would go. The sine of pi over 12. Now this is given to us in radians. You can either change all the angles on the unit circle to convert them to something over 12 if you want to keep these radian fractions. Or I've decided it's a little bit quicker just to convert our radians to degrees. We do that by multiplying by 180 over pi. So the pi's would cancel, and 12 goes into 180 15 times. So what we're trying to calculate is the sine of 15 degrees. And then kind of like the last problem, we found that to get 15, 45 minus 30 is just fine. So now we look at the sine formula, and that one says that the sine of alpha minus beta is equal to the sine of alpha, the cosine of beta. It's a right side up plus minus, so that means keep the same as what I started with. Oops, I wrote an actual beta instead of 30, sorry. Minus cosine alpha sine beta. Now go to the circle and look those up. The sine of 45 is square root of 2 over 2. Cosine of 30 is square root of 3 over 2. Minus cosine of 45, square root of 2 over 2. Sine of 30, 1/2. Multiply tops, multiply bottoms, and let's just put it all together at once. It's going to be the square root of 6 minus the square root of 2 all over 4. Now it says to use addition or subtraction formulas to write the expression as a trigonometric function and then find its exact value. So we're working backwards here. They've already plugged the formula in, and we have to see what they started out with. And the 3 pi over 7 would be alpha, and 2 pi over 21 would be beta. So looking at the formulas, the one that has cosine alpha, cosine beta, and then sine alpha, sine beta is the cosine formula. And because of the cosine formula, it does the opposite sign in the middle. If I've got a plus, I know that means I had to have started off with a minus. So we know that we've got cosine alpha is 3 pi over 7 minus beta is 2 pi over 21. Now we want to put those fractions together. The common denominator would be 21, and that would be 9 pi. And you could leave that the same. 9 minus 2 is 7. 7 pi over 21. And then 7 and 21 both divide by 7. We can reduce that down. Pi over 3. Now go to the unit circle, look up the cosine of pi over 3, and you get 1/2. And so that's what they wanted us to do there.